This is section 8.2, fundamental properties of area. Okay, so last section was on perimeter, now we're going to start talking about area. So the area is a measure of space covered by a two-dimensional region, so perimeter was kind of like the outside of a shape, so all the sides added together, where area is the inside of the shape, or like kind of thinking about a room, it would be like the carpet that covers the floor. So the perimeter would be like the walls around the outside, area is the carpet that covers the floor. Okay, so how we measure area is we measure it in square units. So our units could be miles, inches, whatever, but it's always in square of whatever that is. So square units is the fundamental region used to tessellate in a region in order to find its area. So what they mean by that is basically if we know something is like 3 units by 4 units, what we can do is we can break that up into equal little squares across there, and then each one of these would be a unit squared because it would be a unit by a unit. And then when they say like fundamental region used to tessellate that region, basically these little squares here are your fundamental regions, and then they're tessellating that full shape to kind of fill it up. So that's kind of what they're getting at by that whole thing. But your square units is just, you know, your dimensions basically of your figure. And then depending on the type of shape that it is, we have different formulas that match those areas. Next thing there is area postulate. So on 458, look at that. Let me flip to it here. So looks like there's 4 different parts. So the first thing there, uniqueness properties. So given a unit region, every polygonal region has a unique area. So like if I've got this rectangle here, it's going to have a specific area of 12 units, and that's going to be it. It's not going to change. It's always going to be the same. Okay, so that would be the uniqueness part. Congruence properties. So congruent figures have the same area. So if I had 2 rectangles exactly the same size, exactly the same shape, those rectangles would both have the same area, which makes sense. Additive properties, so the area of the union of 2 non-overlapping regions is the sum of the areas in the region. So basically if I had like a square like that and then another one like that, and I needed to find the area of the whole thing, I could find the area of that one, find the area of that one, add them together, and that would give me the area of the whole thing. Okay, so that's that additive part. And then it says there are rectangle formula, so the area of a rectangle with dimensions L and W is L times W, so basically area is length times width. So to find the area of this square, what I would do is I would do my length times my width, so 3 times 4, which would be 12. Okay, so those are the different things in that area postulate. So a lot of it should probably seem pretty familiar to you guys. Okay, the next thing we're going to do is we're going to do an activity. So if you look on page 459, there should be a picture that's kind of something like this. So what I would do is I would sketch that out on a piece of graph paper or in your notebook or something like that, and then we are going to do some stuff with area. Okay, so what they want us to do in that activity is it says break the polygonal region, so our polygon is just, you know, this inside shape here, into smaller regions and calculate the area. Okay, so one thing we could do here to find area is we could just count up those individual blocks, but they don't want us to do that. What they want us to do is they want us to break this up into other rectangles or smaller pieces. I'm going to use rectangles because that's easy to find the area of. And then we can find our total area by doing that. So what I would do is I'd start breaking this into rectangles here. So maybe I'd go from H straight up and have a rectangle there I could figure out the area of. Could probably do that here as well. G straight up and then D straight up. Okay, so now I've got 4 different rectangles there that I can find the area of. So this rectangle here, it's 2 going that way. The other way it would be from 8 to 1, so that side's got to be 7. So if I use my formula length times width, this rectangle here's got to be 14. This one here would be 3 by 2, so 3 times 2 would be 6. So the area of that rectangle is 6. This one here is 2 by 1, 2, 3, 4, 5. So 2 by 5, that would make that rectangle 10. and then this one is 2 by 1, 2, 3, so 2 by 3 would be 6 again. So then what I would do to find the area of that whole thing is I would just take those separate things and add them together. So I'd take 14 plus 6 plus 10 plus 6, so 14 and 6 is 20, plus another 10 is 30, plus 6 would be 36. And anytime we work with area, we do whatever our label is squared. Since this doesn't have a label of like inches or anything, it would just be units and then squared. Okay. Now, that's not the only way you could do this. You could also split these up into different rectangles here. So maybe say, it's kind of hard without another picture here, but maybe say you split this off as a rectangle, and then maybe you did that top part off as a rectangle, like right there, and then maybe a little tiny rectangle right there, and then another one right there. You could also split it off like that, find the area of all those guys separately and add them together. A lot of different ways you could break that up into different rectangles, but no matter what, when you find the area of each of those rectangles and add them all together, it should always come out to be 36 units. Okay, so let's go to the next thing here. Okay, so for this, we've got a family is installing a ceramic tile on the kitchen countertop, and the countertop is 16 foot long and 2 feet deep. There are 4 parts that will not be tiled: a 3 foot by 2 foot opening for the sink, 2 openings, 2 foot by 1.5 foot for cutting boards, and then an opening 1 foot by 2 foot for knives. And then each tile is 1 foot by 1 foot and costs $2.20. And we've got to figure out how much our tiles are going to cost us in total to tile this entire countertop. Okay, so I'm going to start with a picture here just so I can get an idea of what's going on. So I've got a countertop, and on my countertop I've got different things. I've got a sink. Just going to draw a little sink in here. My sink is, oh, I should do the dimensions of my countertop. My countertop is 16 foot by 2.5 foot. So when they say deep, that just means like back. So 16 foot by 2.5 foot. I've got my sink in there that's not going to be tiled, and that is 3 foot by 2 foot. So 3 foot by 2 foot. It's not very dimensional here, but that's okay. And then we've also got a couple cutting boards. So maybe we'll put one over here. Cutting board that is 2 foot by 1.5 foot. So we'll go 2 foot, 1.5 foot, and then we've got another cutting board. Throw that on there with the same exact dimensions. So 2 foot by 1.5 foot. And then what else do we have? We have knives that go somewhere on here. We're running out of room. Do knives over here. It's not the best design of a countertop, but we've got 1 foot by 2 foot for our knives. Okay, so first thing we've got to figure out here is what is the area that actually has to be tiled. Well, what I would think is I'd go, okay, well, I don't have to tile where my sink's at, so I don't need that area. Also don't have to tile where those cutting boards are going to drop in, and also don't have to tile for the knives. So what I would do here is I'd go, okay, well, I need to figure out the area of the entire counter and then take away the areas of each of those separate things, because I don't have to tile there, so I don't have to buy extra tiles to fill that area because they're just going to be useless. So what I'm going to do first is I'm going to figure out the area of the counter. So my area of my counter would be 2.5 foot by 16 foot. So if I multiply those out to find the area, it would end up being 40 square foot. And then let's do the sink next. So now our sink is 2 by 3. Well, that comes out to be 6, so 6 feet squared. And then we've got 2 cutting boards that are both 2 by 1.5. So 2 times 1.5 and 2 times 1.5, that both comes out to be 3. So 3 square foot. And then last we've got knives there. And our knives are 1 foot by 2 foot, so 1 by 2, which would multiply to be 2 square foot. Okay, so now, since we don't have to tile in these areas here, what I'm going to do is I'm going to take 40 and I'm going to subtract away what all these are to add it together. So I've got 6, 3, 3, and 2, so 6, that would make 6 there, 12 plus 2 would be 14. So if I do my whole counter, 40 minus 14 that I don't need to tile, that would come out to be 26. So I've got 26 square foot of tile I need to order, and then I've got to go back here and it says each tile a foot by a foot, so basically 1 square foot, because a foot by a foot would just be 1 times 1. So a square foot of tile is going to cost me $2.20. So what I can do here to figure out how much I'm going to have to pay for 26 foot is I could just, or 26 square feet, I'm going to take 26 times 2.20, which would come out to be $57.20. So that's how much I'm going to have to pay for 26 square feet of tile, if each tile costs $2.20. Okay, next thing here, we're going to do some conversions. Okay, so we did one of these, I think it was in last chapter, where I talked about T-crossbars, and it's something that you may or may not have learned in your science classes. So T-crossbars is just a way of doing conversions. I like to do this just because I think it makes the most sense to me. You don't necessarily have to do it like this, but it kind of helps me to figure out conversions. Okay, so if I'm going to do some conversions here, what I do is I make a little T like this, and I want to convert 264 feet to miles. So I take my starting amount, 264 feet, and I put that in that position, and then whatever I'm trying to get to, so whatever I want to convert feet to, I put off to the side here. Okay, so I'm going to do some calculations. In the end, I want it to equal miles. So then to figure out if I need to multiply or divide to get to my new measurement, what I do is I use this T-crossbar deal. So I know that I've got feet on the top, and 5,280 feet is equal to 1 mile. So what I can do here is I can put 5,280 feet on the bottom and 1 mile on the top, because what's neat about this is if we think about it as like fractions, what happens here, if I've got a label on the top and a label on the bottom, those can cancel each other out, and then, you know, basically now both of my feet go away, and I'm just left with the label of miles, which was my goal to get to. And then what you do here to actually figure out your calculation is you take your top number times your top number, so 264 times 1, multiply whatever you've got across the top together, which it's just those two things in this case. So 264, and then you divide it by all of the bottoms multiplied together. Well, the only thing on our bottom here is 5,280, so I'm going to take 264 divided by 5,280, and I get 0.05. So 264 feet is 0.05 of a mile. Okay, let's do another conversion here. So this next conversion is a little bit trickier, because what we want to do is we want to take 5 square yards and turn it into square inches. Okay, so I start with my starting amount. I'm going to make my T-crossbar here. Start with my starting amount in the upper left-hand corner, so 5 yards squared, and my goal is to get to inches squared. Okay, so with this, I'm actually going to have to do multiple conversions because I don't remember the conversion from yards to inches off the top of my head. So what I'm going to do is I'm going to go yards to feet because I do know that one off the top of my head. So yards to feet is 3 foot, so I'm going to change this to feet first. So I'm going to put 1 yard on the bottom and 3 feet on the top. Now I put yards on the bottom because then my labels will end up canceling, 1 on the top and 1 on the bottom. Now what makes this one extra tricky here is this just isn't yards, it's yards squared. So how I take care of that is I actually do this twice. So if I put 3 square foot on the top again and 1 yard on the bottom, what's going to happen here is now I'm going to have my yards and yards, yards and yards, and now I'm actually going to be, if I stopped at this point, I would be at square feet because my labels would be feet times feet. So if I stopped at this point, I'm at square feet, but I actually want to get to inches squared, so I have to do more conversions. So now I have to take my square feet, and I need to get that to inches. Well, I also know that conversion off the top of my head. I know that there are 12 inches in a foot, so this time my feet are going to be on the bottom, because then my labels will cancel. And I've got to do that again, so my 12 inches should be on the top here. I have to do that again because I have another foot I have to get rid of, because currently I would have feet times inches, which doesn't really make sense for a label. So I'm going to do the 12 inches again there, and 1 foot on the bottom, because now my last foot label cancels, my foot label cancels there. Now I'm left with inches times inches, which would give me inches squared. So now I multiply everything on the top, multiply everything on the bottom, and then divide those two numbers. So my top here would be 5 times 3 would be 15, times 3 is 45, and then we get to big numbers that I'll need my calculator for. So if I did 5 times 3 times 3 times 12 times 12, I get 6,480. And then my bottom would be 1 times 1 times 1 times 1, which is just 1. So really what I get there is, that can just go away, 6,480 inches squared is the same as 5 yards squared. Okay? Alright, so this one's kind of a little bit of a story problem, but doing the same types of things where we're doing conversions. So here we've got a farm that is 2.5 miles by 1/8 of a mile, and we're supposed to figure out how many square yards the farm is. Okay, so this time we're going from miles to yards. So my farm here is 2.5 by 1/8. So there's a couple ways to do this. One thing you could do is you could figure out your area in square miles right away by taking 1/8 times 2.5. So if we did that, 1/8, 1 divided by 8 is 0.125 times 2.5, which is 2.5. So the area of this land here would be, oh, I didn't even multiply it, 2.5 times 0.125. There we go. Thought that number was weird. So the area of this would be 0.3125, and that would be in miles squared. So you could start with that, already find your area, and then convert it to yards. So you could do, we would have 0.3125 miles squared, and we want to go to square yards. So at the end we would have yards squared, and then our conversion there, 1 mile is 1,760 yards. So when we do that, that's actually miles squared there for that label. Our miles goes on the bottom so that our labels can cancel, and then the 1,760 yards goes on the top. So currently one of our mile label cancels, but I've got to do that again because it's miles squared, and we also want to get to yards squared. Right now I'm at miles times yards, which doesn't really help me get to yards squared. So I've got to do that again. 1,760 yards is 1 mile. So then my mile label will cancel there. It'll finish off that part there. Now I've got yards times yards, so I'm at yards squared. Then I multiply all those top numbers. So I'm going to do that number I got before, 0.3125 times 1,760, and then times that again, 1,760, and I get 968,000. So 968,000 square yards is the same as 0.125 miles squared. Okay, and I didn't have to do the bottoms here. You could take 1 times 1, and then it would just be a 1 on the bottom, but we know that's the same as just that top number there. So that's one way of doing it. Another way of doing it, if it's less confusing to you, it's just personal choice here. What you could also do is you could originally take and find the yardage of your lengths of your farm, and then find your area at the end. So what you could do is you can convert 1/8 of a mile, so these are both in miles, 1/8 of a mile to yards, and 2.5 miles to yards, and then multiply those and find the area. So if I took 1/8 is 0.125 miles and converted that just to single yards, because I'm in regular miles and I'm just going to regular yards, I would do that same conversion there. So 1 mile and 1,760 yards, and I only have to do this once because I've got miles there, miles there. Now my miles labels are completely gone, and I'm left with yards here. So then I would just multiply those top numbers. So I do 0.125 times 1,760, which ends up being 220 yards. So 220 for my yardage there. And then I could do that same thing with 2.5 miles. So 2.5 miles. Oops, a little long there. Converted to yards. Do that same thing, 1 mile on the bottom, 1,760 yards on the top. And then miles and miles cancel, so now I'm at yards, so I'd take 2.5 times 1,760, which is 4,400. And then that's basically, so 4,400 is my area of my new square, or not square, rectangle. So we'll redo this out here. So my one dimension is 220, the other one is 4,400, and then to find the area of those, I would just multiply those two numbers together. So 220 times 4,400, and I should get that same exact answer of 968,000 square yards. Okay, so either way on that is fine. It's just personal preference, what you like to do. I don't care. And really, you don't have to use T-cross bars. I just know that that's what you guys use in science, and that's how I do it. But if you can do your conversions other ways, as long as you can get to that answer there, I don't care. Okay, so your assignment here is going to be page 460, 1 to 11 all, 14 to 18 even, and you're going to cross out number 2. And then in the back of the book, there's a section that's like S. So if you go to page S13 in the back, there's different conversions there. So like, 12 inches in a foot and 3 feet in a yard and that kind of thing. So if you don't know those conversions off the top of your head, you can look back on page S13 and that will give you some conversions that you can use instead of just having to guess, or you could always look it up on Google as well.